learnt about the different prefixes and suffixes in the previous part. Now is the part where we need to understand about how we can break up the system of units into two broad things, that is a scalar quantity and a vector quantity. Scalars will understand that they do not need a direction to be specified. Vectors need both a magnitude as well as a direction. Now, since they are physical quantities, obviously units need to be specified for both of them. Let's try to understand more about the scalar quantity and the vector quantity in this particular unit. So, the next topic that we need to now understand is scalars and vectors. So, what exactly are scalars and vectors? Scalar quantities are the quantities that only have magnitude. They do not have direction. You do not need to specify direction to understand about a scalar quantity. For example, if we talk about a mass, as I had mentioned previously as well, mass does not need a kind of direction to be specified. Mass is going to be the base, it's basically the content any object has. That is how you define the mass. So you measure mass like that. Then if we talk about temperature, temperature also is not going to be dependent upon which direction you are moving. Whether you're moving from north to south, it is not going to be dependent upon the direction. It's an inherent quantity. So again, that's a scalar quantity that we see. So scalar quantities can be added and subtracted like simple additions. For example, if you have a 4 kilogram object and you have a 6 kilogram object, if you have to add the two objects, if you just sum them up, let's say you have the 4 kilogram object kept on the 6 kilogram object, that's going to result into a 10 kilogram object. So it's a linear summation that we talk about, simple summation. Further, when we talk about vector quantity, vector quantities need both the magnitude part as well as the direction. So both the things need to be involved. If either of these things are missing, in that case, it's not going to define the complete physical quantity. For example, if you are being hit, you are a boxer, you are being hit. So obviously it's not going to be possible at any instant of time you will be hit from all sides. You can only be hit from in front, right? So there is a force that is acting. So force can only be acting at a particular direction. So this is a vector quantity. So in this case, you specify the magnitude is 100 and the direction is going to be towards the left hand side. So that is what is a vector quantity. Now vector quantities, when you say that this is what we have, so let's try to understand about some examples. So scalars, there are going to be some analogous quantities. I'll be defining them as analogous because they will have the same dimensions, mind you. These are base quantities that I am referring to. So for instance, distance, displacement. So distance is a base quantity, displacement is also a base quantity. Displacement depends upon the direction in which we are going, right? For instance, you have 2 points, okay? You can go from here to here, or even you can go in a straightforward direction. So if I say that this is my point A, this is my point B, I go from here to here. So that I cover this distance. I am going from A to point B, so I'm covering this distance. Then this distance is not going to change irrespective of whether I go from A to B or I come from B to A, right? It is not going to change. Its value is going to be independent upon the direction. But when we're talking about displacement is actually the shortest form of the distance. So in this particular case, if you go from A to B or if you come from B to A, the displacements are opposite of each other because the direction is involved. So displacement is a vector quantity, distance is a scalar quantity. In the same way, when we talk about speed is a scalar quantity, velocity is a vector quantity. Mass is going to be a scalar quantity. We should be saying that weight is an analogous quantity because the weight has different dimensions to it. But let's try to put it similar quantities. So mass is a quantity that depends upon the inherent quantity, inherent object, inherent things that are kept in that object or they are present in that object. So that is mass. When you talk about the weight is basically how much is the mass at any point on the surface of Earth or wherever. So that is how we define the weight. Then we have time. Time has nothing to do with acceleration. Time is always going to be a scalar quantity. You do not say that you measure time from north to south. So time is not a vector quantity. Acceleration is a vector quantity because it depends upon the velocity. Pressure is force per unit area. So this is not really a vector because even though it depends upon the pressure, on the force, But effectively, if you say that you have a balloon, like if I just try to put a balloon, and you have a gas molecule, so gas molecule is going to exert force in all possible directions, right? So this is the magnitude of the force that is going to exert, and as a result, the pressure is going to be the same throughout the balloon. Okay, so pressure is going to be independent of the direction. Force, yes, force is going to be something which is dependent on a particular direction. You can only hit along a particular direction. Energy does not depend upon which direction you are moving. Energy is only the amount of matter which can be utilized for doing some work. So that is what is known as energy. Momentum, yes, it is a vector quantity. Momentum is defined as mass into velocity. So if you are going from a particular point to another particular point along a particular direction, in that case we say that there is a momentum involved. Okay. Then you have volume. Volume obviously is not going to depend upon the direction, and so is the density. Okay. Now, if you have to add vectors using graphical method, you can add two parallel vectors or anti-parallel vectors using graphical method. So for instance, you have a 2 Newton, you have 4 Newton, you add it up, it gives you 6 Newton vector. In the same way, if you have 4 Newton and 2 Newton is acting in the opposite direction, you find out the net direction. Net direction is 4 Newton minus 2 Newton. So that gives you 2 Newton, but its direction is going to be along the bigger vector. So along the 4 Newton vector is going to be the net direction. Now if you have to identify and add up vectors which are not along the same direction, so this is going to be what is known as a parallelogram law. So vectors we always represented by arrows. What do those arrows represent? So you can see the tip of the arrow, you have the tail of the arrow. Tip represents along which direction it is moving. So it starts from the tail and it goes up to the tip. So this tells you about the direction in which that particular quantity is being measured. So the length of the arrow tells you about what is the magnitude of it. What is the magnitude of it? For every magnitude there is going to be a distance that is going to be measured. Okay, direction is towards right. Further, the length of the arrow represents the magnitude of the vector, as I just mentioned. The direction represents the direction of the vector. Magnitude and direction of the resultant vector, you can find it out by proper amount of scaling. Okay. Now, what exactly is the parallelogram law? You will also study something known as a triangle law. Triangle law and the parallelogram law are exactly the same thing. It's just putting the same wine in different bottle. So parallelogram law, if I have to say, so parallelogram law states that if two vectors are acting at a point, they are going to be represented by the sides of the parallelogram drawn from that particular point. The resultant is represented by the diagonal which passes through that. So let me just explain. So for instance, if I have to just explain, so I have these two vectors, let's say one going along this, other going along this. So they both are starting from this particular point, right? Or it can also be possible that it is in the opposite direction. Now what you do is that you put up, you just draw parallels to both these vectors. So when you draw parallels, and the resultant is going to be given by the resultant diagonals. The diagonals give you the net resultant of the two vectors. In the same way, if you have the vectors like this, in that case, what you do, you always have, in the case of parallelogram law, you are always going to join like this, and the resultant in this case is going to go like this. Okay. Now another method of adding the vectors. So this is what is known as the triangle law. So let me explain. Place the starting point of B at the ending point of A. So what you do, I'll just explain what is being done. So you have one vector here, you have another vector here. You parallelly shift. So for instance, this is your vector A, this is a vector B. You have parallelly shifted such that the tail of the vector B matches with the tip of the vector A. Okay. In that case, the resultant is going to be given by the third side. So this is your diagonal. This plays the same role as that of the diagonal. So in this case, let's try to understand. Place the starting point of B at the ending point of B, or the vice versa. The vector sum or resultant is the vector joining the starting point of vector A to the ending point of B. Conversely, R can also be obtained by placing the starting point of A at the ending point of B. That's what I have done. Now the resultant is represented by the vector joining the starting point of B to the ending point of A. So this is how we find out the resultant. So this rule is known as the triangle law of vector addition. It's very easy. Place a vector, place another vector, which says that the tail of one vector meets the tip of the other vector, and the third side gives you, completes the triangle, the third side gives you the net resultant. So if I have to understand it, so this is how it goes. So as you see, so these are the two vectors. Now you parallelly shift them. Either A you bring it to the tail of B, or B you bring it to the tail of A. In either of the two cases, the resultant is going to be exactly the same, and it's going to exactly match with that of the parallelogram law that you have already understood. So what have we learned? Scalar quantities are quantities that only have magnitudes. Vector quantities are those which have magnitude and direction. Parallel vectors, you can add them arithmetically, simply add them. Non-parallel vectors, you have to use the graphical method, that is, you need to put them, you need to draw a line, draw two vectors, place them or parallelly move them, and then find out the net resultant. Okay, now let's try to understand about the some problems here. So 5 Newton and 3 Newton. Please understand the directions are opposite. So if the directions are opposite, what's going to be the net resultant? Net resultant is going to be 5 Newton minus 3 Newton. So it's going to be 5 Newton minus 3 Newton, which is going to be 2 Newton. Its magnitude is going to be smaller than either of the two. So that's going to be 2 Newton going towards the right. Here you have 3 Newton, 5 Newton, both are acting on the same direction. So both the vectors are going to be added up. So it's going to become 8 Newton, that is 3 Newton plus 5 Newton, gives you the 8 Newton towards right. Now in this particular case, you have 5 Newton going to the top, 5 Newton going towards right. Okay, so what you are going to do, you will have a resultant. How will you find out the resultant? You're just going to join the sides, so it's going to form a square. So the resultant is going to be along the diagonal, body diagonal, and its value is going to be how much? So if I say R is the resultant, so the value of this resultant R is going to be given by 5 square plus 5 square. So that's going to be equals to 5 root 2. 5 root 2 Newton is the magnitude, and it's going to be directed at an angle. How will you find out the angle? Let me also tell you about the angle. Let's say theta is this angle. Okay, so how will you find this out? You can see that this is nothing but tangent theta. So tangent theta is going to be 5 divided by 5, because this side is 5, this side is 5. So this is equals to 1. So theta comes out to be equals to 45 degrees. So this R vector is inclined at an angle of 45 degree with the horizontal. Okay. Further, if you would like to represent it in a vector form, how exactly you are going to represent? You will say that the vector R can be written as 5I, because it has a component along the horizontal direction. So horizontal direction we represent it with a unit vector I cap. Similarly, a component along the y direction, so that's going to be represented by j cap. So 5I cap plus 5j cap gives you the result. You can either use these two, that is, which has the magnitude 5 root 2 Newton and the angle as 45 degrees, or you can use this notation of the vector. The magnitude, if you would like to find out from here, the magnitude is going to be given by square root of 5 square plus 5 square. Okay. In this particular case, in the third case, you see that this 5 Newton, this 5 Newton just gets cancelled. They are oppositely directed, so they are not going to play any role. Okay. So as a result, there is only going to be one vector along y-axis. So that's going to be the net resultant, which is equals to 5 newtons. Okay. Now we have two forces of magnitudes 5 Newton and 8 Newton act on a body. What are the maximum and minimum forces, resultant forces that can act on the body? Okay. Maximum forces are going to act if both the forces are along the same direction. Minimum force is going to act if both the forces are going to be in the opposite direction. Any other angle is not going to give you the maximum or the minimum force, right? Okay. So in this particular case, let's say I have this is a 5 Newton force, I have this being an 8 Newton force. So in this particular case, if they are acting along the same direction, the net resultant gives you something known as 5 Newton plus 8 Newton, that is 30 Newton. If they are acting in the opposite direction, okay, so let's say 5 Newton acts like this and 8 Newton acts like this. So you have 5 Newton here, 8 Newton here.
So as a result, you'll have the net resultant like this, which has a value equals to 5 Newton, 8 Newton minus 5 Newton, which is equal to 3 Newtons. So what is the minimum and the maximum, or the maximum and the minimum? So these are the two forces that are going to happen. Hopefully you understood till this point. Stay tuned.
We learned about the different forms. For example, we saw that the distance is a scalar quantity because it does not depend upon the direction in which the distance is covered, but the length of the path is being covered. But say you are moving from point A to another point B, in that case, you're traveling with the shortest path. In that case, the displacement is important. A displacement is the shortest path between the two given points. Yeah. So that is a vector quantity. So this is the basic difference that we have between a scalar quantity and a vector quantity. We also learned about how to combine the scalar quantities and how to combine the different vector quantities. Now we need to go further. Once we have identified what is a scalar quantity, what is a vector quantity, now we need to identify and say how we can measure the things, because physicality is all about measurements. So let's try to understand about the measurements and the errors that come up in the next part.